All right, 7.6a. So again, this is the last section of the chapter before we have an assessment in about a week and a half. Double angle formulas. So pause me and write all of this stuff down. All right, so we have, yay, 5 more formulas to memorize. Whee! I know you guys are super excited about that. I'm going to show you some tricks to deriving these next time because I don't think we're going to have time on this video. That will make these easier to remember as long as you remember some of the previous identities that we've learned. Okay, so these are just going to be memorized for now, and I'll explain why they work next time. All right, so we're going to be given some information. I'm going to draw a picture for this off to the side because we're going to use the picture for all 3 parts of this. So we know that sine of theta is 12 over 37. We know that sine is y over r. And then theta, it's given that it's between 0 and pi over 2. So that is in quadrant 1. So we know we're going to have a triangle in quadrant 1. And my triangles are never to scale because it's not worth trying to think about. The y value up is y, right? And the r value, and we need to find the x value. And I know you know how we're going to do that. We're going to use Pythagorean theorem. This is not a Pythagorean triple, so we have to just go for it. 12 squared plus x squared equals 37 squared. So I want you guys to pause me and solve that. I'm actually not going to show the work for that because I know you guys can do that. Okay, so we end up with x equals 35. And remember, the last time we did a triangle like this, I think it was in the end of the 7.5 notes, we need to be careful. The Pythagorean theorem is always going to give us a positive because the Pythagorean theorem is just thinking of a triangle floating out in space. Okay, but we're not floating in space. We're on an xy plane, so we need to make sure that we think about the sign, S-I-G-N, of the value that we just got. Since we're going to the right, the x is positive. If the triangle had been in the second or third quadrants, the x value would be negative. Okay, and then from here, it's pretty straightforward. We just need to refer back to these because I don't expect you to have them instantly memorized. Sine of 2 theta is equal to 2 sine cosine. 2 sine theta cosine theta. And by the way, if you needed a calculator for that, that's totally fine. And then sine we already got. We know sine is 12 over 37. And cosine we can get from the picture because it is x over r, so 35 over 37. And again, we're going to use a calculator for this to get the answer. The numbers on the homework are not all going to be big like this, but I just wanted to do one to show you, okay? For cosine of 2 theta, we can pick whichever of the 3 we want. There are 3, they are equivalent, and again, I'm going to show you where these come from next time, hopefully. I would prefer to only have 1 trig function instead of having 2, and I might as well go with the one that's already given to me. So I'm going to use 1 minus 2 sine squared, because I already know sine is 12 over 37. I mean, it's not really much more difficult to figure out the cosine since I already have this, but, you know. And then again, I'm going to use a calculator. When it says exact value, I know you guys know what that means also. It means we want a fraction, a reduced fraction, always, always, always a reduced fraction. And not a decimal, because a decimal is going to be an approximation, not an exact value, okay? So you need to know how to do these on your calculator, leaving them as fractions, not decimals, okay? And then the tangent one, we have this formula. I'm going to show you a shorter way, but I want you to get comfortable using this formula also. So looking at this picture, I know tangent is y over x, so y over x, 12 over 35. So I'm going to have 2 times 12 over 35 over 1 minus 12 over 35 squared. And again, I'm going to use a calculator to simplify this and get that. Okay. Since we already know sine and cosine, we could use our trig identity from 7.4. Tangent is sine over cosine, so tangent of 2 theta is sine of 2 theta over cosine of 2 theta. And then we can use these two answers here. Sine of 2 theta was 840 over 1369. And cosine is that. Let me make the equal sign over here. That looks better, doesn't it? And then to divide fractions, we multiply by the reciprocal. And we end up with the same answer we got before. Okay. All right, one more example, and hopefully my computer doesn't die before I write it down. Otherwise, I'm going to have to go grab my charger really fast and leave you hanging for a sec. All right. I'm given a figure. I'll move my hand in a second. I know it's like impossible to write. There we go. Okay, don't make fun of my circle. All right, so we have this triangle that's created, and the ordered pair is a comma 1. This is my angle theta. And the formula, the equation for the circle is also given. Okay? So I want to think about this theta, and I'm going to use that to find sine of 2 theta. So remember that when we're, like, if I asked you to find f of 2, you would find sine of 2. If I asked you to find f of 7 million, you would find sine of 7 million. Obviously, those would both require a calculator. So if f of x is sine of x, then f of 2 theta is sine of 2 theta. So this is what we're trying to find right here. Okay. So I know that this is the r squared, right? That's the r squared. That's the equation of a circle. So I know that the radius is the square root of 26 because I know the equation of a circle. We're actually going to cover that in a future chapter, but you guys have talked about circles for a lot of years now, so hopefully you remember that. X squared plus y squared equals r squared. And then I can make a triangle. I'm going to kind of extract that triangle out of the picture. I've got the radius. Whoops, that's a 26, sorry. And then I know I go over A and up 1 to get to this point. So over A and up 1. Yeah? And I want to know the value of A. So I'm going to go 1 squared plus A squared equals rad 26 squared using the Pythagorean Theorem. And I'm going to have you guys solve that really fast. So I end up with A equals 5. And then I can use that to help me find sine of 2 theta. Going back to the formula at the top of your page, sine of 2 theta is equal to 2 sine theta cosine theta. I know this is my y, I know this is my x, and I know this is my r. So 2 times y over r, y over r, x over r. And then the x we found was 5, right? And then x over r, 5 over rad 26. So f of 2 theta, I'm going to have 2 over 1, yeah, 2 times 1 times 5 on top, 2 times 1 times 5, and then 1 times rad 26 times rad 26, right? Anything times itself means it's squared. And when we square a radical, the radical goes away. Please don't leave that as an answer. You would never leave that as an answer, right? Okay, so f of 2 theta is 5 over 13. All right, so it's still super weird not interacting with you guys on these videos, but I hope that you're getting some good stuff out of them. We're going to have a Zoom call on Wednesday to answer questions. It's probably going to be our last chance to Zoom before the assessment on this chapter. So make sure you come prepared with questions. I'm looking forward to seeing you guys' faces, to doing some math together, to catching up. Hope you all had a good spring break, and we will chat later.